Moving on to the next section, which covers question 4 only. It states, math terms. Exponential regression is a method used to find an exponential function that models a set of data. The data are not exactly exponential, but the shape of the graph resembles an exponential curve. Also, the table in item 3A shows a near constant factor that suggests that the data are approximately exponential. Use exponential regression to find an exponential function that models the data. Question number 4. Use a graphing calculator to determine the exponential regression equation to model the relationship between the decades since 1950 and the population. The calculator returns two values, A and B. Write those values below. Round A to the nearest whole number and B to the nearest thousandth if necessary. Okay, we're going to talk about how to do this. The first thing we're going to do is we're going to go to Stat, Edit. So Stat, option 1, which is Edit. You're going to see you're going to see a place to input some data, okay? The first thing I want you to know is if it had numbers in it such as so, what I would want you to do is go up to the top, press clear and enter, and it will clear out the entire list. And we're going to type in some data here. The first thing I'm going to do is I'm going to type in my decades since 1950. So we're going to start at 0. We're going to go to 1, 2, 3, 4, and 5. Now in the L2 column, I'm going to put in my population. 160,083 people, 285,278, 488,738, 800,508. And after each number, I'm just pressing enter to go to the next line. 1,201,833. And then 1,998,257. Now, we're going to go to Stat. This time I'm going to go over to where it says Calc. And I want to do a exponential regression. That's what it's asked me to find. So I'm going to go down my list to where it says EXPREG, exponential regression, number 0. And if you press enter, it's going to pop up a thing. It's going to ask you where your X data is saved. We saved that in the column L1. It's going to ask me where my Y data is saved. That's in the column of L2. I don't need to talk about the frequency list. I don't need to store the regression. I'm just going to go to calculate. It's going to generate two numbers for me. It's going to generate the number A and the number B. That is what it's actually asking me to write down here on 4A. It asked me to round that A to a whole number. So we're going to say 170,336. That's the nearest whole number. B, it asked me to round to the thousandth place. That is the third digit behind the decimal. So we would write this as 1.646. My data is incorrect. Notice whenever I type this in, if you go back and look, that fourth number is actually 201, and I have typed in 207. So I need to edit this number by making that a 1. And I should have done that earlier, which was double check my numbers, and I didn't. So now we're going to have to go back through this because these numbers are off a little bit because my data was incorrect. So I'm going to go back through those steps. I went over to calculate. I went to exponential regression. I do my L1, my L2, go to calculate. And notice it changed my number just a little bit. This should have been 170,377. So I need to edit my last 2 digits here. And right here, this should have been 645. So I was off by a digit here as well. So I need to edit both of those numbers. Might not look like a lot, but slight details will affect your graph. The general form of an exponential function is y equals abx, which is the same thing it says at the top here. Y equals a times b to the x power. Use this general form and the values of a and b from part A to write your exponential function that models Nevada's population growth. So this would be y equals 170,377 times 1.645 to the x power. Use a graphing calculator to graph the data points and the function from part B. Sketch the graph and the data points below. And is the exponential function a good approximation for your data? And explain. I'm going to talk about how to do this. We're going to go to y equals. The first thing I want to do is I want to go up to plot 1. So I press the up arrow, and now I'm going to press the enter key. And what it's done is put a black box around plot 1. Okay. In Y1, I'm going to type in the equation that we wrote down for part B here. 170,377 times 1.645 to the x power. The next thing I'm going to do is I'm obviously going to need to change my windows. So we're going to go window. On my X, I'm going to want to go from 0 to 6. 0 to 6, counting by ones. Here we're going to go from 0 to 24 times 10 to the 5th power, which is the same thing as saying 2,400,000. And notice it goes up by 400,000 each time. Now I'm going to graph this. You see these little boxes that were on here? Remember when I had you turn the plot on? Those are those data points that we actually plotted back in question 1. These were just graphed on decades and not on the years. So notice that 0 is 160,000. So that's going to be here. Now remember, this would be 200,000. So it's right below it. Then we had 280,000. That's going to be semi above it. In decade 2, it was 488,000. Going to be close to about here. Then we had 800,000 in 3, so that's going to be right about here. Then we've got in decade 4, it was 1.2 mil almost. So it's right about here. And then decade 5 was right under 2 million. So right about there. The next thing that it did was it graphed this function. Like so. Now, obviously, I kind of went through most of my dots. Notice I'm a little off on a few of them. But as is this graph, it did not go through all of these dots exactly. And we knew that it shouldn't have, based on the fact that this was not a constant ratio. They were all close to about the same, but they weren't exact. So it makes sense that my graph would not go through all of the dots exactly. Make sure you get this graph copied over, and then we're going to move on to the next set of questions.